Low emissivity refers to a surface condition that emits low levels of radiant thermal energy. All materials absorb, reflect and emit radiant energy, but here, the primary concern is a special wavelength interval of radiant energy, namely thermal radiation of materials with temperatures approximately between 40 to 60 degrees Celsius. Definition: emissivity is the value given to materials based on the ratio of heat emitted compared to a blackbody, on a scale from 0 to 1. A blackbody would have an emissivity of 1 and a perfect reflector would have a value of 0. Reflectivity is inversely related to emissivity, and when added together their total should equal 1 for an opaque material. Therefore, if asphalt has a thermal emissivity value of 0.90, its thermal reflectance value would be 0.10. This means that it absorbs and emits 90% of radiant thermal energy and reflects only 10%. Conversely, a low-E material such as aluminum foil has a thermal emissivity value of 0.03 and a thermal reflectance value of 0.97, meaning it reflects 97% of radiant thermal energy and emits only 3%. Low emissivity building materials include window glass manufactured with metal oxide coatings as well as house-wrapped materials, reflective thermal insulations and other forms of radiant thermal barriers. The thermal emissivity of various surfaces is listed in the following table. Low emissivity windows. Window glass is by nature highly thermally emissive, as indicated in the table above. To improve thermal efficiency, thin film coatings are applied to the raw soda-lime glass. There are two primary methods in use, pyrolytic CVD and magnetron sputtering. The first involves deposition of fluorinated tin oxide at high temperatures. Pyrolytic coatings are usually applied at the float glass plant when the glass is manufactured. The second involves depositing thin silver layers with anti-reflection layers. Magnetron sputtering uses large vacuum chambers with multiple deposition chambers depositing 5 to 10 or more layers in succession. Silver-based films are environmentally unstable and must be enclosed in insulated glazing or an insulated glass unit to maintain their properties over time. Specially designed coatings are applied to one or more surfaces of insulated glass. These coatings reflect radiant infrared energy, thus tending to keep radiant heat on the side of the glass where it originated, while letting visible light pass. This results in more efficient windows because radiant heat originating from indoors in winter is reflected back inside, while infrared heat radiation from the sun during summer is reflected away, keeping it cooler inside. Glass can be made with differing thermal emissivities, but this is not used for windows. Certain properties such as the iron content may be controlled, changing the thermal emissivity properties of glass. This naturally low thermal emissivity is found in some formulations of borosilicate or Pyrex. Naturally low E glass does not have the property of reflecting near-infrared thermal radiation. Instead, this type of glass has higher NIR transmission, leading to undesirable heat loss in a building window. Criticism of low E windows equals, since energy-efficient windows reflect much more sunlight than simple glass windows, when these windows are somewhat concave they can focus sunlight and cause damage. Damage to the sidings of homes and to automobiles has been reported in news stories. Low E windows may also block radio frequency signals. Buildings without distributed antenna systems may then suffer degraded cell phone reception. Reflective thermal insulation. Reflective thermal insulation is typically fabricated from aluminum foil with a variety of core materials such as low-density polyethylene foam, polyethylene bubbles, fiberglass, or similar materials. Each core material presents its own set of benefits and drawbacks based on its ability to provide a thermal break, deaden sound, absorb moisture, and resist combustion during a fire. When aluminum foil is used as the facing material, reflective thermal insulation can stop 97% of radiant heat transfer. Recently, some reflective thermal insulation manufacturers have switched to a metallized polyethylene facing. The long-term efficiency and durability of such facings are still undetermined. Reflective thermal insulation can be installed in a variety of applications and locations including residential, agricultural, commercial, and industrial structures. Some common installations include house wraps, duct wraps, pipe wraps, under radiant floors, inside wall cavities, roof systems, attic systems and crawl spaces. Reflective thermal insulation can be used as a standalone product in many applications but can also be used in combination systems with mass insulation where higher values are required. See also, selective surface. References. External links, Window Technologies, Low E Coatings. The Efficient Window Collaborative. Website maintained by a trade organization.